Okay, so I'm going to be solving this problem here. And so we have to figure out the x coordinates where y equals 1 on the polar curve of r equals 5, and then we have to find the angles that make both of those points, that correspond to those points. And so here we know that r squared equals y squared plus x squared. So if we plug in the information we have 5 squared equals 1 squared plus x squared. So to algebraically solve for x, x is just going to equal plus or minus the square root of 24. So now I'm going to plot the points we have on a graph. So here's my very sloppy graph, but we can see that we have 2 points here, and so we're going to need to find the angle here and the angle that is between here and here. So I'm going to call this angle theta 1, and I'm going to call this angle theta 2. So we can find the angle of theta 1 by using the tangent function. So we know that tangent of theta is going to equal 1 over the square root of 24. So I'm just going to take the inverse tangent of 1 over square root of 24, and that will give us theta. So on my calculator here, I got this number. So now we know that theta 1 is equal to, I'm going to approximate, I'm going to round to the nearest hundredth. So it's approximately equal to 11.54. Okay, so now we're going to solve for theta 2. And if you'll notice, these two angles, just here and here, they're going to be equal. And so what we can do is we know that this whole length here, this is going to be equal to 180 degrees. So if we have 180 degrees and we can just subtract this 11.54 degrees, we just subtract that from 180, and that should bring this to this point, which will give us the angle between here. So really all we need to do is just write 180 and subtract 11.54. So we come out with 168.46, and that's our theta 2. So theta 2 is approximately equal to 168.46. And I'll add the degree sign on there. And that is how you solve this problem.